probability distribution. But now we focus in the concept of the probability that a random variable, let's see, a discrete random variable, take a particular value. So what is the probability that the value x, for example, take the value 2, or the probability that the random variable take the value 1? And we're going to symbolize this as the probability that x, the random variable, be equal to the value. Okay, let's see, it's 5 or 2 or 3, whatever value. Or simply you can write probability of the value, and that's it. Everybody understands if you write probability of 2. It's the same that you write what is the probability that the variable take the value of 2. And this probability will be equal to the probability of the event formed by all the elements that you assign that number that is here. For example, if you want to compute the probability of 2, it will be the probability of the event formed by all the elements associated to these 2. Let's see, for example, imagine that you toss a coin, and the situation is that you win $5 if you obtain head, or you win, or you lose $5 if you obtain tail. And the question is, what is the probability of winning $5? If this is the question, what is the probability of winning $5? So it means that this $5 is a value of the random variable. And I understand what is the random variable. The random variable is the payoff. $5 if you obtain head, or -5 if you obtain a tail. So we have that the sample space is this, and the random variable is 5 and -5, and we know that from a previous video. Yeah? Okay, so if we want to compute the probability of obtaining 5, the probability of winning $5, and you know that this winning $5 is just if you obtain head. So it was with this association, yes. So because this 5 corresponds to this, to find the probability of 5, is actually finding the probability of head in this sample space. So actually, to compute the probability that the random variable take a value is actually the same of computing the probability of the event of all the outcomes that are assigned to these values. So in this case, so we have the probability of 5, or the probability of the variable is equal 5. We can write this, or we can write probability of 5. Yeah? We know that from this. Yeah? Then it will be 1 over 2, yeah? Because this is one outcome out of 2 possible outcomes, so 0.5. And this is 0. Because probability of head. So the probability of 5 is 0.5 because the probability of head is 0.5. So the outcome associated to this 5 is 0.5. Okay, let's see another example, a little different. Imagine that the question is this: what is the probability of obtaining 2 heads when tossing 3 coins? So immediately in the problem, tell me what is the experiment tossing 3 coins. And the problem also tell me the random variable, because they are telling me what is the probability of obtaining 2 heads. So the number of heads, it looks like it's the random variable. Then it will be a good idea to see what is the random experiment with all the possible outcomes, and see the random variable with all the possible values. And then see what are the assignation, because the question is the probability of obtaining 2 heads. So I'm gonna see what will be the possible outcomes when you assign to which you assign number 2. Yeah? So, and this for example, there are 2 heads in this case, 2 heads in this case, and 2 heads in this case. So these are the only 3 possible outcomes when you see 2 heads. So remember again in the previous slide that we have this example of sample space and random variable. Now, if we want to compute the probability of 2 heads, the only that we need to do is just look for the events of all the outcomes of the event formed by all the outcomes to which you assign number 2. And then just find the probability of this. So we know that in this sample space there are A possible outcomes. So the probability of 2 will be the probability of this event. And then the probability of X equal to will be 3 out of A possible outcome. So to compute the probability of a random variable, it's a good idea to have in mind the whole sample space, yes, and to see which elements are, to which element you assign the number to which you want to compute the probability. Okay, that concludes my explanation of the probability that a discrete random variable take a value. In other videos, you're going to see what is now a discrete probability distribution, because that will be enough to define a discrete probability distribution. And we'll be seeing other examples. Thank you.